I'll get things started just by asking a simple question: is how to determine how good is good enough? And maybe that'll eventually be answered in the courts. But just this last month in the Human Factors Journal, ARL published an article, and there's somebody from ARL here, as a matter of fact, looking at automation and robots. And they were looking at the imperfection of the automation. And what they found was the higher the imperfection, the less the trust, the more the workload of the operator, which to me it also means that they're more engaged in that. And we were talking a little bit earlier about complacency, and I would assume that if you're not trusting the automation, you're not being very complacent by it. So it gives a thought of, should we be looking at perfect automation when we're applying automation? But back to the simple question is, how good is good enough when you're applying automation?
Well, it seems to me it boils down to, this is somewhere where humans are going to make the judgment, I think. The automation's not going to decide on when it's good enough. And you just have to go through a process. In the aviation world, they have something called certification, which is a very complicated process where there have got to be simulations and then measurements that are approved and agreed to, and flight tests and all those kinds of things. Well, I guess there's general agreement. There's no way to validate that software is going to always work. There's just no way to do that. And now we're at the point where software is developed automatically out of models. So you model something, and then the software automatically comes out of the model, and the software developers really have no idea what's inside the software. So these rare situations where the software would screw up, we have no way of knowing. So there's no way of knowing, there's no way of anticipating, almost theoretically, there's no way of anticipating those rare events of the automation failure.
I would add to that, it was implied in your question, I think, and it's implied in when people talk about it. When you say good enough, it usually is meant as reliability. Is it ever going to fail? But to me, this is ironic. I'm in an engineering department, and I always have to tell people that stop thinking about numbers only. So they think about reliability. Is it 99% reliable? And I'm telling them, well, when you ask me, is it good enough? If 99% of the time it works, but 99% of the time it gives me stupid advice, I'd rather not have it. But if it gives me brilliant advice in 30% of the cases, maybe I really like it. So I think it's also not just about the reliability aspect. That's the one we can measure, so we're all comfortable with it. But I think it's about the quality of what it does in combination with the reliability. But the quality part, people tend not to think about as much, I think.
At some level, there is a degree of quality, or minimal quality, as you say, good enough. And that happens also, to go back to the theme of team and teamwork, that happens also in human teams. Human teams are not perfect, and yet we work with them all the time. So there is an instinctive or natural way to judge whether or not the teammate adds to the performance of the team. What the difference here is perhaps to demand a degree of transparency, of understanding how the automation works. So my question is really, how much do we need to know about the inner workings of the automation, or the control law, or the rules that govern the automation behavior? And I think for mission critical systems like the one we're talking about, I think it's extremely important.
Bob Francis, and I'm former vice chairman of the NTSB and worked for the FAA for 30 years. I think, I don't know whether this is an answer to the question that you asked exactly, but in aircraft certification, there is a cost-benefit analysis done, and there is a figure where you will go and say, it has to be done up to here, but it can't be done beyond that, because the cost-benefit, there's a number for a human life, $2 million or whatever it is. So that, at least in aircraft certification, is the answer to, there is an answer to how much
Okay.
how far you go.
And another quick question for you. Greg of VTTI asks, deaths from automation malfunctions are tragic. Overall, has the crash rate for airplanes gone down with the introduction of automation?
The answer to that is yes. There's good data, and I've seen it from both Boeing and Airbus that shows that it's very graphic. In fact, I was looking at it just the other day. With each successive introduction, with each new generation of automation, the accident rate has come down significantly. There's been a learning curve associated with the introduction of each of those new generations. However, the learning curve goes down quicker, and we rebound quicker, and it goes down to the baseline at a lower rate in each case. So the net result, the bottom line, is that the introduction of automation has improved safety in aviation. There's no doubt about that. What we want to make sure of is that with future generations, that there are not unintended consequences that are introduced, and that it is done in an optimal fashion.